Welcome to the course of complex analysis, and today we are going to start chapter 1, which is complex number and complex function. So a complex number is a number expressed as g equal a plus iota b, where a and b are real numbers and iota is the imaginary unit. Here iota is equal square root of minus 1. So a complex number then can be written as z is equal a plus iota b, where a belongs to R and also b belongs to R. A and b further can be written as a is equal real of the complex number g and b is equal imaginary of complex number g. Now if b is equal 0, that is the imaginary part is equal 0, then the g can be written as z equal a, which is a real number. Therefore we can say every real number is a complex number. Here R is the set of real number, while C is the set of complex numbers. Since we are discussing about the complex number, so first things we have to discuss further is the algebra of the complex number. So for that we first consider the addition, and to do the addition we took two complex numbers, z1 equal a1 plus iota b1 and z2 equal a2 plus iota b2, where a1, b1, a2, b2 all are real number. So now to do the addition, so we have to add the numbers as real part with real part and imaginary part with imaginary part. So therefore z1 plus z2 is equal a1 plus a2, the real part with real part, plus iota, imaginary part with imaginary part, means b1 plus b2. Now if you want to do the subtraction, then it will be also similar way we have to calculate it, and the subtraction will be given by z1 minus z2 is equal real minus real, that means a1 minus a2 plus iota, imaginary minus imaginary, so b1 minus b2. So in other notations, the addition can be re-expressed as z1 plus z2 equal real part of z1 plus real part of z2 plus iota imaginary part of z1 plus imaginary part of z2. Same way it will be for the subtraction. Our next property of complex number is multiplication. So z1 multiplies z2. This is equal a1 plus iota b1 multiply a2 plus iota b2. So here we will do usual multiplication. So a1 with both component of the real part and imaginary part of the second number. So we can write it here as a1 multiply a2 plus iota a1 multiply b2, and then plus iota b1 multiply a1, and then iota square b1 multiply b2. So this can be further simplified as, because iota square is equal minus 1. So we can rewrite the above expression as a1 a2 minus b1 b2 plus iota a1 b2 plus b1 a. Therefore, real part of z1 z2 is equal a1 a2 minus b1 b2, and imaginary part of z1 multiplies z2 is equal a1 b2 plus b1 a2. We already discussed about the subtraction previously, so now we will discuss about the scalar multiplication. So for scalar multiplication, we take alpha belongs to R, which is not a vector, which is a scalar number. Then if Z is equal A plus iota B, then alpha Z will be alpha A plus iota alpha B. That means it will be multiply throughout the complex number components, real part and as well as the imaginary part. Next, we are going to discuss about the division of two complex number. So that means z1 divided by z2, which is equal a1 plus iota b1 over a2 plus iota b2. Now to do the division, we need to discuss another concept of complex number system, which is known as the conjugate. We will give a details example later, but just the idea we will introduce here. So if we have the complex number, let's say z is equal a plus iota b, then z conjugate, we denote it as z bar, is equal a minus iota b. So here is the sign before the imaginary part will change. If it is a minus iota b, then it will be a plus iota b, vice versa. Now to complete the division, we have to find real of z1 over z2 plus iota imaginary of z1 over z2. So to write this expression in that form, we have to multiply with the conjugate of the denominator number. So a1 plus iota b1 multiply a2 minus iota b2 over a2 plus iota b2 and a2 minus iota b2. Then we will do the complex multiplications in numerator and denominator and then simplify. So the multiplication will be a1 a2 and then iota b1 and minus iota b2, so it will be minus iota square b1 b2 plus iota b1 a2 minus a1 b2, and the denominator will be a2 square minus iota square b2 square. Then again iota square is equal minus 1, so we will have a1 plus b1 b2 plus iota b1 a2 minus a1 b2 over a2 square plus b2 square. So therefore we can separate the real part as a1 a2 plus b1 b2 over a2 square plus b2 square plus iota b1 a2 minus a1 b2 over a2 square plus b2 square. Clearly now the expression is in the standard complex number system. So the first part is real of z1 z2, and the second part with iota is imaginary of
Now the last topic
z1
for
over
this lecture
z2.
is the ordering of complex number. So let's have two complex number z1 and z2. Now for the complex number, we cannot compare two complex numbers. Like we cannot say z1 is greater than z2. It is not possible to compare two a complex number because it contains two variable. One is real part and another one is the imaginary part. So it's not possible to compare two complex number. However, the complex number can make the equality can be checked with the complex number, like say z1 is equal z2. So this is if and only if real part of z1 is equal to the real part of z2 and imaginary part z1 is equal imaginary part of z2. Both should be equal, then the two complex number will be equal. In the next lecture, we will give you some examples of the conjugates.